Hi, my name is Dr. Daniel Hending and I'm a postdoctoral researcher in the Animal Vibration Lab at the University of Oxford. So this project has the primary aim of understanding why elephants use seismic communication. The project itself takes place at Mpala Research Centre in central Kenya. It's not very far from Mount Kenya. There's a large population of elephants here. The project has, I guess, three main research questions which it's looking at. First of all, it's why do elephants use seismic communication? So elephants produce these very low frequency vocalizations called rumbles, which these vocalizations are audible to humans and they therefore contain an acoustic component. However, they also produce ground vibrations, which is a seismic component. And what this project seeks to address is why there is an acoustic and a seismic component to these particular types of vocalizations, and are they used for different purposes? Do they convey different messages? Secondly, the project is looking to see how environmental factors affect the propagation of rumbles. So do certain environmental features, bodies of water, areas of rocks, areas of vegetation, even different soil types, how do they affect the propagation of both the acoustic and the seismic components of the rumbles, and therefore is a certain component of these rumbles more beneficial in certain environments? And the final objective of the project is to use rumbles that elephants produce to track and localize elephants in real time. So essentially, we're assessing whether we can use the vibrations in the ground that elephants produce to localize them and track their movements over large areas, which is, of course, highly useful for conservation of elephants, which are, of course, endangered. So the findings will be used to gain a better understanding of how elephants communicate and why they use these very low frequency vocalizations, why they have acoustic and seismic components. Understands how elephants can communicate over large areas. And then also there's an important conservation component to this. So we hope that we can use these vibrations to detect elephants, localize them and then track them in real time to enable us to monitor their populations. The Stryde nodes we're using are deployed in a 3D array covering an area approximately 3.5 kilometers long by 1 kilometer wide. Now the array is deployed between two different bodies of water that elephants regularly frequent to drink water, and elephants very often travel through this area to feed, migrating to different areas, and also of course to visit the watering holes. So it's a perfect location to study elephants. The array itself contains approximately 1,220 nodes, spaced 50 meters apart over 18 different columns and 69 rows throughout the array. The way we've designed this study is so that we're trying to find out how far elephant rumbles can propagate through the environment. So by having an array of this density and of this size, we're hopefully able to determine how far these rumbles, both the acoustic and the seismic components, can propagate through the environment. So once set up, the most beneficial thing about the Stryde technology is the whole thing works as a system. So every component, I guess, works in synchrony. So from the software in the office where you design your array, where you're going to position the sensors, and then you're able to take this detailed map out into the field with the handheld devices. You're able to deploy the devices, the Stryde nodes, at the exact locations that you need to deploy them in order to achieve your objectives. And then you're able to update the locations of the nodes within your array, which means you can easily collect them. And then once you have the nodes back in an office environment, you're easily able to extract all of the data at the same time whilst also charging the nodes for the next deployment. Another really cool thing about the Stryde system is that it also allows you to back up the data to external hard drives at the same time. due to the number of nodes that we're using, it's of course many terabytes of data, and so we need a bank of hard drives in an NAS system to store all this data. So luckily for us, the Stryde system allows us to automatically back up all of that data to our own system as well, which is really, really useful. Whilst I'm relatively new to the world of the study of seismic vibrations, I know that a lot of seismic sensors that people use are often very expensive. They're very bulky bits of equipment. However, with the Stryde system, the nodes are tiny. They're about this size, so they're easily transportable, easy to deploy, and of course they are very affordable in comparison to much of the other more larger equipment that a lot of other people use. So most of the time, once the nodes have been deployed and they're in the soil, animals tend to not really even know they're there. However, to make things just that little bit easier for us when we come to find the nodes again to replace them and service them, we attach lengths of string to them, which breaks the surface and therefore allows us to actually see the location of the node without having to dig around for it. There's been a few incidences where animals such as baboons, hyenas or mongoose have perhaps tugged on this string and have unearthed the node, but as soon as they realise it's not a food item, they just leave the node and we're easily able to find it and replace it. We also had one incident where an elephant stepped right on top of where we had deployed a node. Elephants can weigh up to 8 tons, and however, this node was completely intact and undamaged. So clearly the nodes are very strong and can withstand tampering by animals. The benefit of using a node that you can deploy for a long period of time, of course, is very handy for researchers because it allows us to accomplish other tasks, because we don't have to actually be in the field whilst we're collecting the data. The nodes tend to do the work for you. So of course that's good for us because we're not constantly having to drive from the research camp here all the way out to where our array is, which is 25 kilometres and a 40-minute drive in the car. So whilst we do of course have to go to the array to collect them to harvest the data, we don't of course need to spend large amounts of time in the field, and we're not having to constantly come back and forth from the camp with nodes. So there were some difficulties at the start with setting up the system, purely because it's a new system to me. I'd not used it and it's rather complicated in comparison to a normal computer. However, once your computer system has been set up, and as soon as you've been able to create your plan for the array on the software, it's a very easy system to use. Once you have tried it once in the field and you've collected nodes and harvested the data once, it's all very, very simple. It all works as a system, and it's a step-by-step process.